Here are the solutions to problems 11 through 20 from the Unit 3 review. So for question 11, we want to use the properties of logarithms to expand this expression. So log is really base 10 of y over x to the 8th. Because we have a fraction here, we're going to subtract. So it first becomes log base 10 of y minus log base 10 of x to the 8th. But we still have to do something with the second term. So we have log y, and then that 8 will come down in front, minus 8 log of x. Now, if any of these had numbers, so let's say if we had like log base 10 of 100, we would turn that into a 2 because 10 squared is 100. But there's nothing else we can do with this one. All right, for question 12, what's nice is we're given the graph of y equals e to the x right here. We want to transform it first to make the graph of y equals negative e to the x minus 6. And then we also want to give the range and domain of this. So what we need to first do is take a look at the exponent here. This means first we need to shift 6 units to the right. And then because we have this negative out in front, we need to reflect over the x-axis, because we're taking the opposite of the output, the opposite of the y value. All right, so first going 6 units to the right, we're just going to take this point here. And even though this isn't a nice point, I'm still going to take this point right here, just so we have an idea of how to draw this one. And I'm going to go 6 to the right as well. So it's going to put us just about right there. And then I might take this point right here and then go 6 to the right. So go right about there. And then this gives us a nice curve to try to draw. All right, so this is just showing y equals e to the x minus 6. Now I need to reflect this over the x-axis. So this point right here is just going to go to right there. This point at 6, 1 is going to go to 6, negative 1, and then this point a little bit past 8 and then up to 8. So we're going to go down right about here. And then we have something that looks like this. All right, so first, because it says the range, let's give the range here. So the range doesn't go all the way up. It goes from negative infinity up to 0, but we can't include the 0. The domain goes to the left forever, and it keeps eventually going to the right forever, so the domain is all reals. Okay, question 13. So we're looking at an exponential growth model. If we look here, it's what's being described here is a continuous exponential growth model. The number of bacteria in a certain population increases according to a continuous exponential growth model with a growth rate parameter, so it's kind of like the interest rate, it's just our percent here, of 2.8% per hour. So our time is given in hours. How many hours does it take for the size of the sample to double? So we're looking at some sort of amount that's going to equal, final amount is going to equal the initial amount. And continuous just means it's going to be e to the r times t. So we want this to double, so that means the final amount is just going to be twice whatever the initial amount is. So I don't really have to write that there. I could say it's a 1. But then we just get e. Now 2.8% becomes a 0.028. And then times t is what we're looking for here. So what I want to just do is take the natural log of both sides. So we get the natural log of 2. This is just going to drop down to a 0.028t. So t is going to equal the natural log of 2 over 0.028. Again, this is the exact answer. T would be approximately, we want to round to the nearest hundredth. So go ahead and type that in. We should get 24.76, and we're in hours. All right, question 14 is a logarithmic equation. Notice I have two terms, both log base 2, so I want to get both of those to the same side. So I want to start by adding this log base 2 of x plus 5, and then we'll have equals to 3. So now I can condense my left side, write it as a single logarithm, and because I'm adding, I really want to multiply these two quantities together. So it's log base 2 of the quantity x plus 7 times the quantity x plus 5. So now I'll multiply those together. So we'll get log base 2. This will give me x squared. Outside will give me 5x. Inside will give me 7x. We'll get a 12x. And then 7 times 5 is 35. Now at this point, I could just rewrite this exponentially. So 2 cubed is going to equal x squared plus 12x plus 35. 2 cubed is 8. So now this becomes 8 equals this trinomial. Let's subtract 8 from both sides. It's a quadratic. We want to solve by factoring. So we'll get x squared plus 12x, 35 minus 8 is 27. We'll try to factor this. We should get x plus 9, and then an x plus 3 in the other one. 9 plus 3 will give us the 12 in the middle. 9 times 3 will give us a 27. So x plus 9 equals 0 leads us to x equals negative 9. X plus 3 equals 0 leads us to x equals negative 3. But we have to check. So if we go back to the problem, we can't take the log of a negative number. So when x is negative 9, this is negative, so we can't keep that. When x is negative 3, this will work. We'll get log base 2, negative 3 plus 7 will give us 4. Negative 3 plus 5 will give us 2. And we could take this further. Log base 2 of 4, that means 2 to what power is 4? That's going to be 2. And then we get a 3. Log base 2 of 2 will give us a 1. And 2 is equal to 3 minus 1. So x equals 3 is our solution. All right, another logarithmic equation. Best way to start this is to rewrite it exponentially. So we would get 81 to the 1/2 power is equal to x. A 1/2 power means it's the square root. So we're looking at a positive square root of 81, which would just give us a 9. We don't need a plus or minus. And we can't have a minus anyway because we can't take the log of a negative number rather. So x is just equal to 9. All right, and another similar one here. It says write the exact answer though using either base 10 or base e. So I'll use both. I'll solve this both ways. So if we start with our problem, I want to keep the x plus 5 in parentheses. We're going to do a base 10 first. And all this means is I'm going to take log base 10 of both sides. So I don't have to write the 10. So this would give us 8x times log 7 is going to equal the quantity x plus 5 times log 8. I want to distribute the log 8 over here because I need to get my x terms all to one side. So we'll have 8x log 7 is going to equal x log 8 plus 5 times log 8. So now I can bring my x terms to one side. So we'll get 8x times log 7 minus x times log 8 plus, or equals 5 times log 8. Now I could factor out the x. I'll continue over here. So we'll factor out an x. We would have 8 times log 7 minus log 8 equals 5 times log 8. So now x would just equal 5 times log 8 over 8 times log 7 minus log 8. So that would be base 10. Pretty much for base e logarithms, that would just be the natural log. So we could also have x equals, wherever we just have a log, we would have a natural log. So it becomes 5 times the natural log of 8 over 8 times the natural log of 7 minus the natural log of 8. This would be base e. Because if you recall, natural log is really log base e. It said just the exact answer. We did not have to approximate this. All right, for 17, two parts here. First part we want to rewrite as an exponential equation. So this just becomes 3 to the negative fourth equals 1 over 81. And that should make sense because this really becomes 1/3 to the positive fourth, which is giving us 1 over 81. But this is all they were asking for. For part B, rewrite as a logarithmic equation. So we have log base 8, and then it's of 64 would give us 2. So 8 squared would give us 64. All right, the easiest way to start this is to make a table of values. The answers don't come out too nice, so we just have to estimate it. But let's just make a table of values here. Let's just go from -2 to 2. So first we're going to have 5 halves to the -2nd, which really becomes the reciprocal, so 2/5 squared, which gives us 4/25. So we have a point of -2 and then 4/25. Next we'll have 5 halves to the -1st, which becomes 2/5 to the 1st, which is 2/5. So then we have -1 and then 2/5. Next one, anything to the 0 power is 1, so we have 0, 1. Then we'll have 5 halves to the 1st, which is 5 halves. So we have the 0.1, 5 halves. And then we have 5 halves squared, which becomes 25 fourths, which we could say 4 goes into 25 6 times with 1 left over. So that might be helpful when we go to graph. 2 first. All right, so as we go to graph this, we're going to go to -2, and 4/25 is just a really small number, so we just put a dot slightly above the x-axis here. Then we have -1 2/5. 2/5 is a 0.4. We're going to go almost to halfway. Then we have 0, 1. 1 and 5 halves is 2.5, so that's a nice one we could put right in the middle there. And then we have 2, and then we'll go 6 1/4, so right about there. And we just start to graph it as such. Okay, for number 19, here we have the entire graph of function f. We want to graph the inverse of f. So let's go ahead and make some points here. So right here we could say on f, we have the point -8, -6. We'll go here to the corner. Looks like 2, -4. And I'll go right up here. We'll say 4, 3. So now on the inverse, we just switch the x and y values. So we would have -6, -8, -4, 2, and 3, 4. So we'll plot those points. So we have -6, -8. Always double check your points too. -4, 2, and then 3, 4. So we'll connect these. And remember, there's always a nice way to check is if we were to graph the line y equals x, that's just going to be a line that goes right through the origin, has a slope of 1. It looks like these two graphs reflect over that line. So just to point out, this is the graph of f, this is the graph of the inverse of f. And the last one for this set, another exponential function we want to graph here. So again, let's make a table. Let's just start with y equals 2 to the x, and then this would just transform by shifting 3 units to the right. So we'll have x, and then we'll have y equals 2 to the x. So again, let's go -2, -1, 0, 1, and 2. So here we'll have 2 to the negative second, which becomes 1/2 squared, the reciprocal to the positive exponent. So we get a 1/4. So on y equals 2 to the x, we have the ordered pair -2, 1/4. 2 to the negative first becomes 1/2 to the first, which is just 1/2. So we have -1, 1/2. We'll have 0. 2 to the 0 is 1. We always have 0, 1. 2 to the first is just 2. So we'll have 1, 2. And then 2 squared is 4. So we'll have 2, 4. So we'll plot those points. So -2, we're going up a quarter, a little bit right there. -1, 1/2 right here in the middle. We have 0, 1. We have 1, 2. And we have 2, 4. We could even fit one more in there. 2 cubed will give us 8. We could even fit that in there. All right, so we'll connect these. And this is y equals 2 to the x. So now we'll shift 3 units to the right. So I'm just going to start right here at 0, 1, and we'll go 3 to the right. Here we have 2, 4, we'll go 3 to the right. 3, 8, we'll go 3 to the right. And then right here at this point, we'll go 3 to the right. And then even right here. All right, so looking at the domain here, our graph goes to the left forever, to the right forever, so it's all reals, -infinity to infinity. The range, the furthest it goes down is 0. We don't include it, but 0 to infinity for the range.